Hey everyone, welcome to today's video. Today I'm gonna talk about electricity. We've explained nuclear a bit, just how it relates to plants and everything, but a big deal also that's in physics and everything is electricity. Electricity leads to the biggest breakthroughs in science. It could through magnets, through particle accelerators, and through Star Trek. I'm going to talk about that today as well. Now, people can see electricity, it seems just like an energy moving, and it's that. It's blue, it's light. Number one thing about electricity is it is 100% made out of hot light matter. So photons, electricity, an electron is just like quantum entangled photons sticking together, and that's an electron. Then in the electricity, the electrons are quantum entangled to each other. But that is quantum entanglement that's not solid, but more like moving and like a sponge, so to speak. So that's the first, most important thing is to understand what electricity is. I have made predictions and written patents about new magnets. So I'll explain that first of all, which is very easy. People know in a factory where they make magnets, it is the materials that all go into the magnets. They melt them, then they let them cool down, and they get a magnet. Then they just let electricity go through a magnet, and what happens then is the most important thing. When electricity goes through a magnet, the electrons in it become entangled. Because these electrons of electricity are entangled, so do the ones in the magnet. And that's how one gets a magnet. The electrons in it quantum entangle, therefore they are like stationary electricity. But it's still not solid. And the breakthrough I think I have made, that I have written down, is one before electricity is let through the magnets that are in the factory. One puts them together like that, applies pressure here about 50 kilograms, that they are squeezing tightly together, but they are two separate pieces, and then lets the electricity through the magnet, the one that entangles them. Then the electrons on top of this magnet and the one on top, they too entangle to each other, is the great breakthrough. That's most likely 100% correct. And then the two magnets, even if they are separate, the electrons on top of them and on top of this one are entangled to each other. And then that is quantum entanglement of two magnets, of electrons, millions, billions of them entangled. Then this magnet could be on the moon, could be on a satellite, and one can send digital information from one to the other through some very little tight wires that go into both. One sends through quantum entanglement information to this one, and that's like a new digital age. It would be like it sends digital information, internet, wireless, it sends telephone, pictures and so on, but without any power required between the magnets. Because the electricity of both that is stationary, quantum entanglement of electrons works between each other, and through billions of them the digital information is sent. So that's the first breakthrough of magnets. Plus that might even be able to send electricity from one magnet to another. Then there would be a revolution on satellites, let's say. One would no longer need solar panels, which are very, very heavy. One would send from the Earth electricity to the satellite, and that would be a great big revolution. Another point about these two is, let's say there are two big magnets on two satellites, and this is here like Mars. Then electricity would be let through the magnets. It goes from this one to this one, that are big satellites, and then as it goes through the planet, let's say Mars, or any planet that doesn't have a magnetic field, once the electrons get to the core, because they are going from one satellite to the other, once the electrons get to the core of the planet, the core is so tight, and neutronium, in my physics all cores of planets and moons are neutronium, and they have to be because of mass, incoming mass and outgoing mass. So when electrons hit that core of solid neutronium that's on the bottom of the planet, that's the core of the planet, they cannot get through. The electron hit into very dense neutrons and they stay there. And then for a month, one would say, satellites are circling like that around the planet and filling the core with electricity. Then in that very extremely hot neutronium temperature of the core of the planet, the electrons are stuck there, they become entangled through a new, like a very, very hot entanglement. There is evidence of that, of electrons being entangled in very hot places. That's magnetar stars, neutron stars that are very magnetic. So through this magnet entanglement, we would even have the possibility, if we send electricity through it, to form a magnetic field of a planet, and cheaply, very easily, and everything. Because the electrons would go from one towards the other satellite, but they would be angled exactly to go straight, and once they hit the core of the planet, they will be stuck there. They cannot get through. There could even be multiple satellites, and they would fill the core with electricity over a month period, and then all those electrons in the core of the planet would stay there, be stuck, entangled, and the planet gets a magnetic field. I mean, our magnetic field in biophysics of planet Earth is just neutronium, neutrons and electrons in the core of the planet, because simply protons cannot exist in such a hot temperature. They melt and turn into energy. That's why the sun, the top of almost any sun, and our sun, is plasma made of protons. They turn into light and they go away. But as one goes deeper in the sun, in my physics, the core is made out of strictly neutrons, and in some cases even electrons in suns. So that's electricity. To point out the magnets. I also have a lot of ways and patents how to make neutronium even magnets, but they require very, very strong forces to keep the neutrons together. Neutrons can be separated from protons, let's say in hydrogen, by very strong heat. The hydrogen will turn away and go into plasma and energy, but the neutrons will remain. Then they are picked up, ionized, then they are filled with electricity, with electrons, and then they have to be entangled in a solid piece of matter with forces that we don't yet have, but in a new particle accelerator that I explained, we could. Another thing that I showed, let's say those are the two magnets being quantum entangled to each other. Well, this one could be a ton heavy magnet. This one could be a kilogram. But still, the ton and how many electrons are in this one are still entangled to this one. So this ton of electrons, how many electrons are in it, gives electric magnetic field to this one and makes it that much strong. So the magnetic field of this one will be that much strong, how big this one is. And then people can understand how we can make a way, way better particle accelerator, which is quantum entangled magnets to many behind them and many large ones, and then that gives a particle accelerator that can make antimatter very fast and everything. Antimatter and the accelerator is a whole new, that will be in the following videos. This is now electricity and magnets that I thought to point out. So that is one way of making very strong magnets. Another way that I thought to do it is one gets a magnet, the atoms of a magnet, then fills it with liquid helium. Liquid helium, number one, is very, very small, so it can go in between all the atoms of a magnet. It can stay there, plus it has its own electrons, 4 electrons helium has. And it makes the densest magnet possible, plus helium is extremely superconductive, which is perfect for particle accelerators. People know at CERN all the magnets are superconductive. That is a very important thing. Then graphene is applied over the magnet that it sticks like a coat of graphene. No helium can come out. Then helium can even be turned into solid, and it is like minus 320 and something in some cases. So that gives the densest magnet, the coldest magnet and the most superconductive magnet. And then even that one can be entangled to one bigger one, and that really can give us the particle accelerators. But it is all about having liquid helium in it and everything, and then letting electricity through the whole magnet. It entangles all the electrons and gives a magnetic field a lot stronger than an ordinary magnet. But to simplify it, this electricity that is here, the same thing is in the magnet. Just the electricity is a bit far away, so to speak. The electrons are going around the atoms, but they are still entangled to each other to create the field. Plus, in a particle accelerator, then electricity is even added to the magnets to make them even more electrically strong. So those are two patents about the best magnets possible. The neutronium one is like the toughest to do. That will be in following shows and everything. And that is the most important thing to understand about electricity, that they are quantum entangled electrons. Now another even better prediction, scientific prediction, which has tons of evidence, that's part of my physics as well, is to make solid electricity. Now let's say dynamite. A person has dynamite. Dynamite is like a glue. It's like a plastic that the atoms are chemically entangled to each other, and the dynamite blows up. The dynamite, blows up, and that is the whole thing. How much it blows up, it blows up. Then one takes, let's say, nuclear matter, makes it dense and everything, it blows up, and the shock wave is what it is. Then one takes neutrons, just neutrons, and entangles them into a solid piece of matter, and one gets a supernova explosion. But then if one goes even smaller, that's electricity. And that is 100% E equals mc squared, therefore just energy, but just an energy of light, not fire. Electricity doesn't really have fire, it is more a form of light. So if one entangles into a solid piece of matter dense electrons, which are quantum entangled photons, that is the most dense piece of matter, hot matter, possibly made. So that will make a nuclear explosion look like little, nothing special compared to that. And then once one has solid electricity, he taps it into what I explained, the magnetic, the mass of the galaxy. That solid electricity can tap into the mass and outgoing masses of the galaxy in its gravity. And according to its acceleration, force equals mass times acceleration, but this is more like acceleration equals mass times the outgoing force explosion, which is the shock wave. That's how I would explain it. So the faster that solid electricity is moving, the more extremely strong shock waves, not explosions, but shock waves are just coming out of it. Solid electricity could not even explode. Most likely. It can go faster than light and not explode, because the electron transfers incoming mass into outgoing mass the fastest and everything, because it is 100% energy and E equals mc squared. So solid electricity really can give a Star Trek. There are tons about that, equations and everything, which will be explained about that whole physics and everything. I shared these physics with the magnets and everything. I shared with some people, shared it with a lawyer, I thought, to protect it in court and everything. But it seems people, they just stole it, you know. They didn't want to talk to me. They just thought maybe to steal it and everything, and then I thought, you know, I'm not even going to concentrate on that. It's just some people, you know, who can't even make over 300 euros a month and something. And I was even stupid to share such things with them, but just had to point it out. You know, there could be some stories coming from here, from Montenegro, like about my physics, but it's all my physics. It's not really any of theirs. I was just stupid to share it with some people, and they just thought to steal it, and that's the whole story. But all of it, I will explain tons and tons more about it, especially electricity. So solid electricity can give us actually Star Trek through a proper and correct physics through it. Because solid electricity can give a shock wave. We talked in the last video about the nuclear shock wave, how it comes to be from the density of the neutrons and the protons and nuclear matter. Well, the density of electricity is like an electron is a lot smaller than a neutron and a proton, 30-something times smaller. Then electron is entangled photons, so that's even smaller. And then that solid matter explosion would give shock waves that are even stronger than supernovas. Now scientists think that supernova shock waves are like weak, but they don't take into account that a supernova shock wave is millions of times faster. It just moves the entire mass of the sun, the matter and energy of the sun. And that's why shock waves of supernovas, they appear small on telescopes, but the force itself is millions of times stronger and faster, just it's moving all the matter of the sun. So the shock wave seems slow when a supernova explodes, but it's actually a lot stronger and faster. It's just lifting a lot of weight, so to speak. But solid electricity can give even stronger shock waves coming out of it than even nukes, than even supernovas. And then people can understand that can really give Star Trek, because such strong shock waves coming out of the exhaust of the ship or a rocket would go so fast. It's like really fast and everything. So this is one of the equations about electricity. There is a lot more. I'll zoom in later so people can see it. Now I'll just explain it. So the acceleration of energy, solid energy, which in this case is the electricity, which divides into quantum distance between electrons, which equals weight. Now, a very important thing in nuclear physics and in solid electricity physics is how much space is there in between matter, because that's empty space. There's no energy there, there's not mass there, mass is in the particles themselves. So the solid electricity divides into quantum distance, which equals weight of the whole matter. So the closer the electrons are to each other, just like in nuclear physics, the better the whole process goes. But to squeeze the matter that tightly, nuclear or electricity, one needs extremely strong forces to do that. So that's like in future physics. So quantum distance between electrons when they are solid matter, that is very important part in nuclear physics and in this physics. So that equals the mass, which divided by the weight of the solid electricity, and times that one gets the speed, which is 5,775 to see precisely mass of that matter gets those speeds of movement, and the division of mass is like a core, which is divided by 3,085, gets the weight of the electron. So the electron gets that weight when the mass passes through it. So just like a gravitational pull, solid piece of matter, solid electricity, mass is coming into it, spherically it's coming into it. And as mass passes through it, that's weight of each electron. That too is how nuclear matter works. That's how all matter works. But in these cases, it's very important to get the biggest shock wave possible. So as mass is, we jump up, we fall down. Like if I was standing on a scale, the mass is pushing me down to the scale. So just like that, in a solid electricity, mass is coming into electrons and pushing them. And that's their weight, basically. That's also very important for nuclear physics and everything. Just the difference here in solid electricity is the intensity of mass that gives that weight, because an electron can hold out million times more mass than other matter. Electricity moves at the speed of light through wires, and electrons function and work just fine. If we moved at the speed of light, that would be like very, very bad. We couldn't, our matter couldn't hold out, couldn't cope with that. But electrons can do that just fine with no problem. But in the gravity of the galaxy, there's no weight on us because we're too small for it. So therefore, a starship can go the speed of light and faster than light. So the weight of electron is totally different because it is made just of photons. Everybody knows photons move at the speed of light and they function just fine. So they are like electricity and light are sort of matter made to go fast, so to speak. So from that too, people can understand how that can lead us to the Star Trek, where we need to go at the speed of light and faster and so on. So the force of speed, 5,775 through second speed squared. So that's the speed in 1 second squared. That's when the matter is moving 775 light years in 1 second. That's the speed right there that is talking about. The force of speed, 5,775 light years is there. That exact speed squared. And that is through a new law of physics that I have written, that is acceleration equals mass times the force of speed one gets when he's moving through space. So in short, that new law that I wrote, similar to Newton's law, is acceleration equals mass, but in space, not in speed. But acceleration divided by 3,085 gives the incoming acceleration number of mass into matter. And then through that, one gets the outcoming speed. That works for all explosions and everything, but especially for this type of things. And in the end, it says that is the possible speed limit of Star Trek. People cannot understand how much faster that is than the speed of light. Because the speed of light, I mean, Einstein taught that, but that's something old. That's something from 100 years ago. People then thought, oh, nothing can go faster than light. But that's just being sort of not productive and not moving forward, being stuck in the past, so to speak, and not being revolutionary and changing things for better. Things can go faster than light. Darkness is a smaller particle, and it goes faster than light. 540 kilometers per second, a particle of darkness moves. So Einstein taught that because he was observing reality through something old, something from 100 years ago. But to make Star Trek, we have to go faster than light. That's basically it. And the whole universe is there, the whole galaxy is there. If we don't go faster than light, then how are we going to get there? Would be a simple explanation. So the universe is basically saying, if you believe you can't go faster than light, well, then you'll never get to the galaxy, you'll never get to the universe. So, but yes, we can, and people will see through evidence and through similar equations that yeah, we can go faster than light easily. Once it is all understood and everything. So this is a formula that is about like formula through a new law of movement, which is about solid electricity. And that new law of movement is acceleration equals mass times the force of speed coming out, like shock wave. But it works for rockets and for everything. And then people can see through that formula, just which is short and easy, a new way better. All kinds of acceleration can be made for rockets, for rocket fuel, and so on and so on. Because if we make more solid and strong shock waves coming out of little tiny atoms of fuel or molecules, well, then we get faster acceleration, which would be a simple explanation. Now just zoom in so people can see that is the whole equation right there, and the explanation and everything. And there is a lot about this in about 4 books about Star Trek and how to make it and everything. But the big idea is to make solid electricity, because the shock wave coming out would make nukes look like a match, even that small. Number 2, solid electricity does not explode. Solid electricity is just energy, so it's not fire, basically, it's light. So it can move at the speed of light, give shock waves, but will not explode. That will also later be explained. And I would just like to point out, you know, this is a book that I wrote to publish. I have a lot of ideas and everything, of course, that I have. But this that I'm explaining, this is some things were very revolutionary and great, were very great patents and everything that worked. The magnet things that I told people, that works. The entangled magnets one to each other, that's correct, that works, and many things. But I wrote patents, not in this book, but in the next one following it, and it's all about patents, millionaire, billionaire patents and everything. But this is a book, I would even like to publish it in England, in the West, I mean, and translate it. If there's an interest, of course, in everything. But through the videos, I will explain it in piece, especially this book. This is like the best physics ever in human history, to me, I would say. It is the best explanation of gravity. I could just point that out. If this is the center of the galaxy, a black hole, and there's a sun here and a sun here at the end of the galaxy, they both make a circle at the same time. And that is a revolutionary explanation of gravity. So the sun here that makes one circle around the black hole is going 10 times slower through mass than the one at the end of the galaxy. Because scientists say that suns move 750 kilometers per hour through the galaxy. But let's say if this one here is moving 750 kilometers through the galaxy, then this one is going 10 million kilometers per hour. Because this one goes through 10 times more space, that sun, than this one. And if it goes 10 times through more space, it's going through even more mass, that much more mass. So the mass coming into the sun at the end of the galaxy is 10 times faster and stronger than one here. And then that explains that supernovas would happen at the end of the galaxy more than in the center where we are and everything. And that explains that. So to say that all the suns are moving at the same speed is actually incorrect. Because all the suns in gravity, it would appear, are moving at the same speed. But through the space of mass, they are not. Because this sun goes through space 10 times less space than the sun at the end of the galaxy, because the space there is 10 times bigger. But they make the circle at the same time. So in time and in gravity, both suns are moving at the same speed. But through space, and mass is actually space, and how fast something goes through it, that's what gives mass, gives explosions and everything. And that also in part explains solid electricity, because the faster it is moving, the faster shock waves will come out of it. Is the big point through gravity, to understand the field of mass and everything. And that is one beautiful, beautiful math of all the mass in the galaxy, which will be explained in future shows. And a clock, how to measure it anywhere in the galaxy and everything. and the correct map to know the gravitational pull of every piece of matter in the galaxy, just by knowing where it is and how fast it's moving. So this is another equation about electricity. So the energy of electricity, solid electricity, the core of solid electricity equals its mass, which we just explained, I explained just earlier. And that is identical to outgoing mass. Outgoing mass is the shock wave and what will propel a ship to go at the speed of light. And that is divided by times speed of outgoing mass squared through acceleration. So an important thing to know, this mass right here and this mass are totally equal. That's why it says that they are identically equal to each other. Because how much mass comes in, that's how much it comes out. It is always the same. How much water you pour in a glass, that's how much you can drink. Gram per gram, so it's just like that in mass. How much mass one can absorb from the gravitational field, that's how much can come out as explosive shockwave. So, and that outgoing mass is divided by the speed times the speed of outgoing mass squared through acceleration. So it says through acceleration because it is the faster the core is moving, times acceleration, the more outgoing masses, stronger ones and faster ones come out. And that happens, mass turning into outgoing mass shockwave, through the transfer of mass. Now that's quantum realm, extremely important physics and beautiful for all matter in the universe. Any piece of matter you can see has a transfer of mass, and that's how, and it carries information about it, sound. That's how we pick up sound from Jupiter with the radio telescope, because its outgoing mass is sending it to us and we just pick it up with a radio telescope. Let's say that's one example. That's how the sun shines upon Earth. Incoming mass, which is the gravitational pull of the sun, comes into the sun, joins at the extremely dense neutronium core and comes out as outgoing mass, picks up photons and then shines upon Earth, which would be a simple explanation. So transfer of mass is something that all matter has. It even carries images in my science, like a camera. Right now you are seeing an image of me talking, but through my physics that means that outgoing mass coming out of me is showing you an image of me. And then it goes into the lens of the camera, it goes into the little glass inside, goes into electricity, then goes on the internet, and then you see it. And then it comes out as photons to you. So that too is electricity and light. So a screen of, let's say on a phone, on a computer, well, that's just tiny little dots of light that comes from photons. So, no, it comes from electricity, sorry. Electricity turns into little tiny dots, different colors, and that's how you see that's how you see the image that is portrayed on a computer, on a phone, and so on. So what you see actually is like us working together with reality. And through this understanding you would see that in part all reality is digital. Is a digital reality, so to speak. But just real reality is real, you know. It's an image that is constantly changing and moving, but it's an image of reality. It's not an image that's like a picture fixed, but it is non-stop changing and everything. So that all happens in my physics through outgoing mass, which comes into matter, mass comes into matter, joins through its quantum entangled bits, then transfer of mass happens, and outgoing masses then carry an image of those atoms and how they are entangled. And in my physics, that's how you see me. So, and that's how people see everything around them and everything. Glass that's on top of a camera, it just sort of focuses the light to go into a small sort of like mirror. Then the mirror takes that small focused image and carries it into electricity, into computer world. Then electricity carries it as information, and then it goes on the internet and everything as information. And then that information, when you see it on your screen, it is portrayed by little dots of light. So a TV screen that's pixels just has dots, and that information tells the screen which dots to light up, so to speak. And then you see an image and everything. So that's the equation there. Transfer of mass, which here is extremely strong. Maybe the biggest one it would be in the universe, because it would give Star Trek. It would be even faster than light, that shock waves coming out of it. Let's say if a Star Trek ship is moving 10,000 times faster than light, then the outgoing masses would be twice faster than light. But it is times acceleration. It is times acceleration, therefore it is. Therefore, the faster it's moving, the faster it's gonna move. But that works for all rockets in a little tiny bit, even for the space shuttle, for this and that. Because the faster the space shuttle is moving, the more mass its fuel has in it. And the more mass the fuel has, times acceleration, the more mass is going to blow up when the hydrogen blows up behind the space shuttle. But this really works when you get out of the Earth's gravitational pull and everything. If you're going to Mars and so on. And many future shows will be even about that. How to go to the solar system, best fuel, thermal hydrogen, entangled hydrogen, to make a very strong fuel, which is just hydrogen atoms that form like an atom that is like thousands of hydrogen atoms sticking together as one liquid, as one solid, and then a liquid of that blows up. So then that will go 10 times faster than the space shuttle and so on. Because all the hydrogen atoms would be molecules that have 10,000 of them in them as solid pieces of matter. Then the mass of hydrogen increases because they are entangled to each other, which happens through a cooling process of liquid nitrogen in the patents and many magnetic fields and so on, ionized hydrogen, and then one would get that thermal hydrogen fuel for a space shuttle that could go like all over the solar system easily then and so on. So then the equation goes further, times and through infinity through time. So the incoming mass and outgoing mass, that's forever, you know. A mass is endless. The whole universe and every single thing in it, in my physics, is mass. And the incoming mass, like our gravitational pull, it's endless. It's forever, ever. Forever and ever. And it can be a lot faster and a lot slower, according to acceleration of matter. So the incoming mass and outgoing mass are infinite, but we would need matter that can hold out to withstand all that mass. And that's what electricity is best for. And that infinite through time is divided by speed squared, which is always smaller and equal to 5,654,761 light years per hour speed squared. That is sort of like the speed squared that it can reach through physics. But it could reach even faster ones. So I'll zoom in now so people can see this equation as well. It is right there. That's the equation and that's the explanation right there below. And many more will follow such equations that are very, very good. And of course, many people think that things are about what Einstein said. You know, and no offense to Einstein, but that's just old, you know. That it can go faster than light. Why not? Why can't it go faster than light? An image coming from an Andromeda galaxy comes to us like a trillion times faster than light. It is constant. A telescope picks up an image of the Andromeda galaxy in a split second. And that's evidence. But okay, that image is information. It's not matter. That's information coming to us from the Andromeda galaxy a trillion times faster than light. But that also is evidence that some things do go faster than light. Now this goes into explanations that people believe how old the universe is. Once you understand that there is this galaxy, MAC S0647JD, it is a name given to a galaxy that's very far away. And it cannot be seen with a telescope with a redshift. And the distance to it is 13.3 billion light years. And this is what led people to believe that the universe is 13-14 billion years old, because they believe that an image from that galaxy comes to us at the speed of light. But they don't understand that that's totally incorrect. An image of that galaxy can come here in a few seconds. And once people understand that, that gives us a million times more correct math about the universe, about how to go to the universe and so on. I'll just see what in the end it says. Well, okay, that's now something different about that galaxy. But people can understand through that can even be proven, like a sun. Like a sun that we see, a star. Well, we see it instantly. When we look up at the sky, we see the stars instantly. We don't even need a telescope. But okay, those are stars and planets near us. That sometimes Jupiter or Mars, light hits them and it bounces off and we see it. But people don't understand that in the universe, a lot of things go faster than light. Mass goes millions, trillion times faster than light. Okay, now let's say this is a black hole, the center of galaxy. It is also center of mass of a galaxy. And there's a sun, let's say right here at the end of the galaxy. We would be somewhere about here in the Milky Way, and that would be the end. It would be like, we are somewhere here, the last one is here. Well, the black hole that's at the center of the galaxy, mass is coming out of it. That's dark energy in my physics. And it even hits nearby galaxies and affects their movement. But that dark energy mass coming out of a black hole is the field of mass in which our sun gets its mass. Then the mass of our sun joins in the center through transfer of mass, comes out as light and hits us. So in part, dark energy is what shines upon us in our sun. But let's say the furthest sun away in our galaxy, the furthest one away from the center of the galaxy, it gets mass in a split second and gets trillions of tons of it. In a split second, and it is so far away, and just there people can see through evidence that mass is so much faster than light. That's like trillions of times faster. And if we tap into that mass with like a solid core of electricity or some other technology, we can go faster than light too. Real evidence really says that. It's not like it's just a story. And many about that will be explained in the future videos. So this is another equation, very, very simple. The energy of the electrons, this is through sort of Einstein's explanation. The energy of solid electricity, which is of the electrons, equals mass. And mass is identically equal to outgoing mass times infinity divided by the speed of acceleration squared. So this whole process, energy equals mass, which equals outgoing mass, which is the shock wave or explosion, is always times acceleration. So the mass, incoming mass and outgoing mass are infinite, and that infinity of mass is divided by the speed of acceleration squared. And that's like a short, very easy explanation of Star Trek and many, many other things and so on. So to zoom in on that equation, that's the explanation right there. That's the whole explanation. People can translate it if they like, of course. I just didn't have money for that yet. So there's some new plants coming, and very interesting, there is strawberries right there. 1, 2, 3 so far strawberries. Okay, people, so now I'm gonna show how to water strawberries and little plants. The strawberries are right there under in the eggshells and stuff, and the little plants right there. This is Mexican habanero and Italian cherries, these little ones. So now I'm going to show how to water them like the best way. So this is the part for the strawberries I'm going to go. Now for the strawberries, roots are very good. People just leave them in the ground, but this is like a better advanced way to do it. Now these are my roots that are already like enriched atoms. These are maybe 3 times enriched, but one person finds in a forest are probably about this good and so on. But any roots can do, you know. What a person can find, that's okay. So that's the roots I got for today. They're still seeds. The strawberries are seeds. So it's not really, doesn't really need that much now. But later, a bigger amount is just needed. So that's the roots that are gonna go in. Then the next part for the strawberries is this stuff. One can take chocolates or stuff, but this is cacao, like parts of a chocolate seed, but it's just unprocessed, unchanged and so on. But chocolate might do as well, but this is a powder, so it'll turn into a liquid easily and very quickly. So that goes in. The roots, that's a little bit too much, but that's okay. And since I'm watering other small plants, this is for the next part of them. But this stuff also goes in for them as well. Then the water goes in. So that's now just for the chocolate. Some honey could also be good, can be added. So, but now they're seeds. So that's, I think, good enough for the seeds for the strawberries. Now I also went in with the green of my plants stuff. Took some flowers from them, for some leaves and some branches from them, and I put that in to go into the little ones. Because these little ones right here will be made out of the enriched atoms that these plants already are. So these are, let's say, up to 5 times enriched atoms. That means those will be 6 times then. And so on and so on. So the ones next year will probably be 8 times, 9 times enriched, and so on and so on. Oh, that's the liquid right there. The liquid, the cacao, and the roots and the leaves from the plants. Now these are from these plants and roots and stuff. And now the new ones are being watered with them. Like that, so to speak. So these new plants, this is now a thorough liquid, but it turned into a liquid easily and everything. So these new plants will be 1 times, the atoms will be enriched 1 times more than these. So they will be better, and that is understandable and everything. So how good these are, the next ones will be even better. Then the next one after that will be made out of these plants, and so on, better and better and better. So they are watered now. These are the Italian cherries right there. So they're doing about a centimeter a day, some more, some less, but they're doing okay. They're doing okay. A centimeter a day they're doing. This is just some parsley that I put in the ground just to see will it work. Just to test that out. But the Italian cherries are doing fine right there. They're growing about a centimeter a day, and that's Mexican habanero plants right there. They're also doing okay growing and everything. So by summertime they should give fruit, the cherries. And now another experiment I did these days was green onion. This is like a hack to do green onions at home on your own, and I did this one right here, and people can see this grew in 2 days right there. That's 2-3 centimeters right there that grew in 2 days, and I saw this blend was very good. This is just water and honey, so it seems it's going very well. So this is made out of honey and water just, and it's growing very nicely, very well. So this one I added a new one where I put some other blends into it. This is all the carbon on top. People usually do this just with water, you know, at home to have green onions. And it's very easy to do in 5 minutes and everything. So now I added this one today, and tomorrow I'm gonna add another one. This one's got eggs and stuff in it that I would usually put in. It also has in it the onions themselves. So it's blended in a blender, onion things, and it has in it eggs, and it has in it water, of course, also. So these were doing very well. So now I'm testing these. I did this, put them in today to see how will they do and everything. So then I'll see which one is better, this one or this one. And this is the first fruit edible thing that came out from everything, and it's proof, and it seems it's going very well and fast. And then tomorrow I'm gonna add another one to have 3 of these to grow. But in a vertical farm or anything, this is great to make onions this way. And enriched ones, very easy, very cheap, and people can do it, tons of them, kilograms of them. Very good idea and everything. More a checkup on the plants and everything. People can see right here the suckers are growing very well. The leaves are very green, very rich, very healthy and everything. The big tomato plants, the dinosaur trees right there, naturally growing the way it's supposed to. This one as well is just like that. Just one sucker right there was cut off, and then I thought it was a bad idea. But you can see how green the suckers are and how good it's going. But now what I'm doing with the bigger plants, these, is I'm thinking they just need a little bit water these days. So I'm just watering them with water now, because the ground and them are full of the atoms I've been doing. So now I'm thinking to give them a little bit water and to let the flowers come come to be faster. These here dried away. They came to some point and stopped because of the temperature or something. I don't know why, but they stopped. So now I'm concentrating a little bit on these, on the flowers and everything. So on the flowers, and now I'm just giving them water a few days. That one, and that one. Just so that they get a little bit moisture and water and go a little bit in that way, because they have been getting the other stuff so much and everything. So maybe it's too much every day to do it. Sometimes it's okay just to put water in, because the carbon atoms of food and everything that are there, they're in the ground anyway. So even if just water is put in, sometimes it will pick them up and so on. So this is another equation about electricity. The energy of electricity equals its mass, even then one gets the outgoing mass, but this is just the energy of electricity equals mass times 6.5681145 E 19 kilometers per hour speed squared. So that is the calculations. Now I have evidence about these things. It's not like some story. That is the possible speed that Star Trek core ship could really reach. Through this technology and understanding of the space of mass and the correct math about it. That is also something that will be in the future shows how to calculate and know the exact speed of all masses in the galaxy. A whole show will be just on that. And that helps out a lot in understanding Star Trek for real and how it can really work. But through nuclear physics, it is simply understood. A nuclear bomb works just as good as how dense it is. The denser the atoms are packed together, the more shock wave there is. But electrons are a lot smaller than nuclear atoms, thousands of times smaller than a nuclear atom. So when they are densely packed, everybody knows electricity explodes just in a calm, nice way. A light shining from a light bulb, that's just an explosion of electricity. But solid electricity does not explode because there's no force strong enough to explode it. So that is the number that can be reached through space once one understands the correct math about the field of mass. Many people talk about the Higgs field, they talk about the gravity through Newton, through this, to that. And Newton, I think, is the best explanation of gravity so far in past science. But once one mathematically correctly understands mass, then it is a whole other ball game. Mass is something thousands of times more powerful. Mass is actually a field to explain gravity and mass. Planets are moving around the sun. We are moving around the sun. But the gravitational pull, what pulls us down, is mass coming into Earth, according to acceleration around the sun. So if we were further away from the sun, although their planets are moving slower in gravity, then there would be a lot more mass and we would all be stuck to the ground and everything. But planets closer to the sun they then have less mass, but they do move faster than our planets. But in a solar system, it's different because every planet can move a certain speed. They can even move in opposite directions and so on. So in suns, it's very simple in a galaxy. The further away it is, the more mass it has. But in solar system, planets move, it is the same as far as mass is concerned, but some planets move at certain speeds. It's not fixed. Some can be far, far away, but still move very, very slowly. So that's an explanation of gravity and mass in my physics. Imagine if a person, let's say, planets are like people on a bus. And gravity is the bus that's moving. But a person sitting in a chair in a bus, well, he's not moving. he's sitting and standing still. So a planet around the sun is not even moving. A planet is just in its gravitational space, that it's where it's supposed to be. But gravity, the field of gravity, that's what's moving. So that the bus is moving, but the people in it are just sitting in their seats, and that's it. So that's how planets go around the sun. The field of gravity is moving. But in that field, a planet is sitting, standing still, doesn't move at all. But what the planet is moving then through is not gravity. In gravity, standing still, but it is gravity that's moving. What a planet is moving through is mass, the field of mass. And that gives us gravitational pull, that field of mass that we are moving through. And it's like that for all matter, atoms, subatomic particles, neutrons, protons, any piece of matter in the universe. That's how it works. Its gravitational field moves it, and it's moving through the field of mass according to its acceleration in space, its distance from the gravitational center, and so on, which will all be explained in a future show. So the big point is, the faster something moves through space, Newton explained that simply by saying force equals mass times acceleration. Force equals mass times acceleration. So one gets more mass by the more acceleration there is, the more mass a person gets. One gets that from Newton's second law. But Newton saw it that he needs a force for that. Of course, that force is gravity. That's doing that in the universe, moving everything, and it gives mass and acceleration. But to get more acceleration, we need to start off with something and so on. And then that's what fuel is for, fuel in a car, that's what rocket fuel is for, and so on and so on. But that is a beautiful and most correct way to understand gravity. Gravity is a field that comes out of gravitational centers, black holes or gravitational centers that are in matter. When they're outside of matter, that's a black hole. And the mass and gravity come out of that center. In our case, it's our sun. Both of those centers of mass and gravity are inside the sun. And that moves Earth around the sun. But the mass coming out of the sun hits us, but it's a field. Mass is like a place, a field. And then how fast Earth goes through that field, that's our gravitational pull, and pulls us down. And then it joins in the center of Earth, which is a neutronium core, and it has to be because of transfer of mass. And it is very, very hot. Everybody knows the deeper people go, the hotter it is. That's because it's a neutronium core. If there was liquid lava there, liquid metals, like people say, metal cannot transfer mass nicely and everything. So that's why in my physics, because it's a liquid, it doesn't work that way. And then in the center, neutronium center, mass joins through transfer of mass, comes out as a quantum realm force, quantum gravity, if people like to call it, and it picks up darkness. And that's why we have nighttime. In my physics, it is explained that way. So I thought to show people new things that are going on. This I did today. I put some lettuces. Those are crystal lettuces in there with water and honey. That's right there. I put here in water and honey. I saw that worked very well for them. But these I put in today, so they didn't start growing at all. The lettuces, this is iceberg. This is a local one, and those are crystal lettuces. To see how that's gonna go, simply. I put in these onions yesterday and they grew a little bit. People can see it right there. I put these in 3 days ago and this is how much they grew. So I realized that it's a very good idea, that it's going well, and then I put in some more. And more onions I plan to do later. which will be for the creams and everything. The cream package, like right there, and then onions in it to see how that's gonna go. So the plants are doing fine. There are the trees. That's the dinosaur tree. They're untouched, unchanged, so growing naturally. And it's almost to the top. There's 3 meters in this room from top to bottom. And the dinosaur tree, even if no suckers are cut off, is still the biggest. People can see by its size that it's still doing better than these other two. Although this one is doing very nicely and as well. Looking green and looking very nice and everything. And now I leave it open so that they start getting used to the outside air and temperature. I leave it open during the day. The cucumber is doing nicely and everything, has a few flowers blooming, but they're supposed to give, bees are still supposed to come over. That didn't work out with the flowers. What I told in previous shows, it didn't really work out. But new flowers are always coming, and I plan to put the cucumber outside quickly so that it's on the floor. I would have done that earlier, but the winds here are very strong and might destroy them all. So this plant is doing okay. These are doing okay. They're being watered with the same stuff, people know. I tried out some new things on strawberries. I tried out this that worked out for strawberries. This is like a cacao powder, like of chocolate and everything, and that works very well on seeds of chocolate with some roots. So roots are put in this stuff and it's whizzed, and that's to water the chocolates with. That's to water the strawberries with. And people can see right here that the strawberries started to grow. That's one right there, one right there, and one right there. So they're doing okay. But strawberries sort of grow slower than other plants. They need time and so on. And that one strawberries and that one. So we'll see in the future how that goes. These little seeds are also working well. This is the onion I put in just to see how will it work in the ground. And as people can see in the ground, it grows like 3 times slower, 4 times slower than in the water with honey and everything. So that was working out well. So this plant right here, only one sucker was cut off. And people can see that it's looking like green and very, very nice. Sort of even nicer than others. It has like some nicer color and everything. The suckers are growing very, very well. And they are having already flowers and everything starting. But sort of the color of it is very nice and looking like it's a tropical place or something. And this is the one where the suckers were cut off. Yes, it has flowers, and these sort of, because of the temperature or over watering, they sort of dried out. But now I'm working out those problems with the flowers. Yes, I don't know much about plants. I just got into this a few months ago. But I'm learning about it and everything. I work in physics more and everything, but plants are not that, I mean, as far as gardening and things are not that hard to figure out. So far I have figured out many, many things and everything. And this is interesting to point out. These are growing like a centimeter a day. These are the Italian cherries that I mentioned earlier, and they're looking nice and growing and everything. And over there are the Mexican chilies that are also going to be good. But when I water these little plants, now I take atoms and greens from these plants. But they are small now, so not many atoms are needed really for them. I take some roots from there and some greens from these plants, and I water these little ones because these are more enriched now than what I can find around where I live and everything. So I would just cut off, let's say, this one branch with it and water those. So those are going to be even more enriched than these ones. And then when they give fruit, I'll take those greens and then do new ones, and so on and so on. And by then I'll probably have a place outside where I do all this and everything. In September I plan to open like farms and everything, ones that work in the winter, vertical farms and so on. So this is another short, very easy equation to understand. It's through Newton's law, but more detailed, so to speak. Newton said for every action there's an opposite and equal reaction. Now, this is sort of like explaining that, but through more detailed explanation. It is action equals reaction, and the action that is explained in the text is acceleration of matter proportional to what happens. Acceleration of incoming mass equals the density, is always equal to the density of the matter itself, and that is equal to the reaction, which is outgoing mass, which is shock waves, carrying of signals, carrying of sight, and so on. It equals the reaction, which is divided by outgoing mass, which equals acceleration of energy, which is divided always by the size of the particle. So outgoing mass equals acceleration. That is very, very fast. That's radar, that's light, that's darkness, that's sound, and so on and so on. But whatever it is carrying, the speed of that energy or sound and so on is decided by the size of the particles. So a photon is a photon, its size decides how fast it's going to go. Darkness is darkness, a cold aron, I call it, a cold photon, and its size decides its speed, 540 kilometers per second. Through energy, so that happens through energy. Outgoing mass equals acceleration divided by the size of the particle. So the smaller the particle, the faster it goes. The bigger the particle, like radiation, the slower it goes. So that's what happens through energy. And times that one gets sight. One gets sight. So if a bomb explodes, the first thing, fastest thing that comes out of it is we see it. That's actually the fastest part of an explosion, or any piece of matter, so to speak. And that sight is divided by the biggest speed squared. That's the biggest speed coming out of matter, but that's information, you know. That's not matter, so that's the biggest speed in this part, I mean. In this part of seeing things and equation. So the action is matter and mass coming into it, according to its density, size, speed, and so on, and that is equal to a reaction, which is outgoing mass, which equals acceleration of particles, according to their size, through energy, times which sight happens, and so on. But sight happens even without energies coming out. Although all visible matter has some energy coming out of it. Light or darkness would be the biggest ones known, and so on. So the acceleration of outgoing mass is always faster than energy. That's how we see the Andromeda galaxy and so on. But the speed of outgoing mass when it's carrying energy is divided by the size of the particle that it's moving. So radiation, some radiation particles are as heavy as atoms. So those are like very slow, big energy, so to speak. That's why radiation is harmful, because those like heavy radioactive particles, they come into the body and they stay there. And then they stick to atoms and poison them and so on. So need to see now, and that is sight. That is times that happens sight. Is how it happens in the whole visible universe. That's how sight happens, as information being carried. And that is the biggest visible speed in the universe. That is the biggest, I wrote down, the biggest speed, visible speed in the universe. So that which gives sight and everybody sees everything, that is visible, that is the biggest visible speed in the universe, is the explanation. And that is something also beautiful through Newton's physics, but it is sort of different and explains a bit more about propulsion. A simple law that says acceleration always equals mass, and times that one gets the acceleration, the speed of the force coming out. Like I explained in nuclear physics earlier, although in explosion that's not really that important. In space propulsion that's very important and helpful. An explosion, the faster it's moving, a bomb, the more mass it's going to have, so the more it's going to blow up. That's sort of through Newton's second law. And that's like a beautiful for all space propulsion law, even law of mass and the universe, which says acceleration equals mass times the force. So that's like Newton's law, but flipped around to be more understandable in a way of propulsion. And that force, in the end, that's outgoing shock waves and explosion that give us movement through space. It's a very beautiful when it's understood like a law. It can even be said it's a law because it's really like that for all fuel, all rockets, and even Star Trek that I mentioned, and so on. So that will be all for today, and like, subscribe, leave comments, of course. I love to hear what people say about it. And if people are interested, I will point out all these books, and what I'm explaining soon will be translated, and they will be going to the West, they will be going to the world, copies to be sold as books and so on. But many things I can even more explain. They are books that I wrote years in the past. This one I wrote a year ago or something, but now I know even a lot more about it and everything. But are really beautiful books and everything. As people can see, it's a totally new physics, but very revolutionary and can lead to very great things. The physics that I work on is mainly, in a big part, supposed to be correct, of course, but to lead people to great things, you know. Some people say, you know, E equals mc squared, that it's the biggest, that is the biggest equation ever. And in the past, it had meaning, of course, and it has meaning in it today, but there is millions of times better equations than that. Once one goes into this physics and sees how it's, because what did E equals mc squared give us? It gave us a little bit understanding how the sun works, and it gave us bombs, and Einstein basically better GPS, so to speak. So, you know, that's how I observe physics. Not to offend or something, but like, you know, what did it give us? If you examine the world globally today, who helped the world the most? And you have to, by evidence, see, that's how I see it, that it was actually Tesla. Because out of all the inventions of the past and everything, what are we using the most? And that's two-way electricity that invented Tesla. That's the internet. That was in big part also Tesla like pointed towards it, so to speak. Just it took people a long time to realize that, how to make it. But Tesla was talking about the internet in the 1915s and so on. Okay, then there are cars. Rockefellers made the first car engines and cars. Cars are also used, of course. Boats, planes, thousands of things. But if you examine the world, who really helped all of us and influenced our lives the most, well, you could say it's Tesla. Faraday you can mention, but we're not using that electricity, we're using two-way electricity. That gives us computers, the internet, everything, and so on. And in second part, if you examine who helped out the world the most, you would of course say Newton. Newton led to the Industrial Revolution, to understanding the universe through math and physics, not through some fantasies and something, You know, so before people thought, that factories and all those things couldn't even exist. Second Newton's law gave people steam engines and so on, the one I just mentioned. And Newton's laws, I would say, I love Newton like a lot, as far as physicists in the past. And Newton's laws are even today correct. And they will be correct in 1,000,000 years. But what Newton's law means, as far as the whole universe is concerned, it will take humanity like trillions of years to understand just maybe 10% of what Newton's law really means. Because Newton said force equals mass times acceleration. But how many things in the universe are doing that? Billions of galaxies, trillions of stars and planets and so on, and they're all doing it in a mathematically different way. So just of that, there's like an endless amount of matter doing that. Trillion, with a specific map to itself. So what Newton's law really means is like, it'll take a very long time to all of it know, I'm saying so. And so that'll be all for today, you know. And like I said, like, subscribe, leave comments, and like I said before, I know people are not going to believe that, but really, I know the quantum realm like a lot. If people have any problems in physics and everything, they can just leave in the comments. And in the next show, I'll explain it, try to help out in that, in a technology or something. So bye.